A very common model that we use in the math workshop in order to solve multiplication problems is through the use of an array. The definition of an array is an arrangement of columns and rows. And when you take the two factors from the multiplication problem that you're trying to find the product for and make those the dimensions of your array, you will either create a rectangle or a square. If the dimensions are the same, the shape of the array would be a square. In this case, we have a rectangle which consists of 16 columns of 12 squares and 12 rows of 16 squares. And so by the construction of the array, the total of this problem, the product, 16 groups of 12, the number of square units inside represents that total. Once students have an array constructed, they need to find a way to determine what the total number of square units are. They could, in the early stages, simply count by ones, and then once they get more familiar with the use of the array, they'll find more efficient ways to solve. And one example of that might be to break the array into two different parts, which we call decomposing. And in this case, because there are 12 rows, we could easily decompose this into 10 rows and 2 rows. And by doing so, we would create two smaller arrays to where we could efficiently determine what our partial products are, or our subtotals. In this case, we have 10 rows of 16. In 10 groups of 16, students are able to solve problems like these mentally in the intermediate grades, represent a total of 160 squares. And then we are left with 2 rows of 16, and multiplication as repeated addition would be represented as 16 plus 16. They could determine that as being a total of 32. Now with the two partial products, they simply need to add them together. 160 in this grouping plus 32 here to determine the total number of square units in the array, which is 192, the answer to our word problem. As always, we request that our students write answers in a complete sentence. So in this case, they would write, Ms. Frizzle bought 192 cans of soda.